Okay, welcome to the next section. This is similar to the last section that I'll show you how to set up the D1 Mini that has the OLED display on it. Very much the same sort of sequence of steps and commands. Once again, here are the two devices. In this case, we'll be doing the OLED shield. In the previous section I showed, in the previous two sections I've shown how ESP Home works. In this case we'll be looking at a display component. In this case it will be this SSD1306. You do have a lot of other displays which you can add on. So you could take another D1 Mini, interface it to another display like I've done one of these. And obviously you even could create your own custom display, your own custom components. This is now in the ESP Home, the OLED component. So you can see in this case, this is one of the ones I explained. This is a 128 by 64-bit display, almost a standalone display. Often, you can see this is Adafruit and it's used in Arduino projects. In this case someone has written this component for ESP Home. Same thing, you need the MQTT component again, so that this is how it will become a publisher through MQTT into the Raspberry Pi. And in the case of the OLED display, it is actually now an input device. So it will receive MQTT commands from the DS18B sensor and will then display the real time every time the Dallas device sends a new temperature reading. It will be updated on the display. This is what the YAML file looks like. I use Visual Studio Code. In this case you can see the settings are different. You need to define the I2C pins D1 and 2. You need to give it a font file, so I will include the source and all the other requirements in the uploads. And then this is what I mentioned before, you have a text sensor, so it uses MQTT subscribe, so it subscribes to this topic, update OLED temperature. And if you were to send an MQTT command to this topic, it would pick this up and then it would get returned through this ID here, DST temperature, DS18B temperature. And then in the display section here, you say you're using a SSD1306 I2C. It's 64 by 48. This is the I2C address, and then the lambda functions, which I will describe, just give more detail into how lambda works. What it effectively does is passes this through to the C++ compiler and uses a function that now you give an XY position, the font that you've defined over here, as well as the temperature, and you then convert it to a string so that you can actually display it on the display. Once again, these are the three most important commands: compile, upload, and run. Okay, in this case, this is very similar to the DS18B20, but this is the OLED display. You see we have our project here. This is Visual Studio Code. This is the YAML file, display OLED YAML, and you can see here it actually has all the details I showed you in the slide. So what you would do is go to your command line. You would okay, just going to connect my device in. You would then go to ESP Home, and then it's display OLED.yaml, compile. and as you can see here, it runs along. It's actually getting the dependencies, building everything. Okay, as you can see, I showed you before, that was built before, so we can do a clean. That will clean all the files out, and if we now do a compile again, it'll now do a compile from scratch. So it'll go fetch whatever it needs from the internet, and this it only does this once. If you build it again a second time and you only change one line in the file, it only builds the latest changes. So it has a proper build make engine, so it only compiles the changes from time to time. Alright, once again you can see the size, how much memory it took. Okay, the next command of course then would be to do an upload. You can see there I've connected it to this the same COM port again. So in this case you can type 1, you'll see now it's updating the flash. Right, and there it's finished flashing. It's only a matter of a few seconds. If I now open the terminal emulator and we go to that COM17, you'll see there it is now. There it's running now, doing a Wi-Fi scan. There it shows how it's connected to the device. MQT is connected to the broker. There did an I2C scan and found the now what you got now is, because I have a Raspberry Pi running with the MQTT broker, you can actually see the readings that are coming in from the temperature sensor every 10 seconds. That's why I showed you this tech sensor. So this is really amazing that you can see it in real time. I guess anything else? Yeah, obviously what you could do again is go back here. If you made some changes, you could then, if you wanted to do an upload again, this time you could tell it now 2, and it would now update. If I switched back to the terminal, you'll see how it's showing here, how the over the air in progress, you know what I mean. There it's finished, there it's rebooting, and obviously now there it's going through the whole process again, finding the Wi-Fi, scanning for Wi-Fi, connecting, finding the display. You know, pretty amazing. In a matter of seconds, you can really there it's picking up Dallas temperature sensor readings again, and then these are the sections, very much similar to the DS18B20. So you have the, except this is called display OLED. You got the Wi-Fi credentials. It's got another IP address. Obviously, it must be a different IP address from the Dallas the DS18B20, so that you wouldn't want them to conflict. Same thing now. You can have a web server, a logger, the same broker, same over the air, and this is the things that are different now for the display YAML file. The 2 pins that are used for I2C, the font. And as I described earlier, you can have a number of these text sensors. If you have a display that has multiple lines, you can actually have each line as a different text sensor, and you can then control through this command here where you want where you want it to print. So you could actually have now, you know, DS temperature, humidity, pressure, and then each one of these would be a line, and you'd obviously have to either control the line number or the position, the XY position, so that each display value is on a different part of the display. Once again, this is the teraterm log. You can see here how, once again, it connected to the Wi-Fi. And you know what I mean. So And then this is the interesting part here. You can see how it actually scanned the R2C bus and found a device on 3C, which is the display. These are the two SDA, the clock and data lines that you need for R2C. And then this is what it looks like. This is what, at the end of the day, this is the temperature reading shown on the display. This is quite a small display, but you do get big ones, and you get, you could actually have a dot matrix display. You could have a Nokia 5110 display, which is an LCD. So once again, as I've said before, your imagination is the only limit.